So guys, in 2020 paper, if you take structures, so there are around 11 questions from structures. Okay, and there are 3 questions from vibration. So we'll discuss one by one those questions. Okay, so let's see the question number 1. Okay, so in question number 1, it is question number 9th from GATE 2020, and it is the first questions from structures part. So what is given? Which one of the following condition needs to be satisfied for phi equal to ax power 4 plus by power 4 plus cxy cube to be considered as an Airy stress function? To be considered as an Airy stress function. So guys, in these questions we know what is the Airy stress function. Airy stress function satisfy biharmonic equation, right? Or it is what? Delta power 4 phi equal to 0. Okay, so this equation, if you write in expanded form, what it is? It is dou power 4 phi upon dou x power 4 plus 2 dou power 4 phi dou x square dou y square plus dou power 4 phi upon dou y power 4 equal to 0. Okay, now substitute this phi and differentiate. So when you substitute phi and differentiate, if you check d power 4 upon dou x power 4, it will be coming as how much? It will be coming as 4 into 3 into 2 into 1 x. So it is what? 24x. So 24x, you guys write 24, not x. It will become constant. So 4 time when we differentiate, it will be 24a. Then this second term, which is dou power 4 phi dou x square dou y square, it will come as 0. Okay, and the third term, which is dou power 4 phi upon dou y power 4 equal to, it will be coming as how much? It will be coming as 24b. So if you see the solution, if you substitute in this equation, what you get? 24a plus 24b is equal to 0. So from here we get a plus b equal to 0. So the correct answer is B. Now guys, in your GATE exam, there are many questions from Airy stress function. Okay, there are many questions from Airy stress function in previous years papers. This is one of the easy question. There are some other questions also from Airy stress function. Okay, where you need to deal with boundary conditions. If time permits, we'll take up those questions in subsequent classes. Okay, so this now Airy stress function is given by English mathematician, and it is in absence of body forces. In absence of body forces, your compatibility equations will be what? This. Okay. So in terms of the stresses, and we know here what is your sigma x. sigma x from Airy stress function, we know it is what? Dou square phi by dou y square. What is your sigma y? It will be dou square phi by dou x square. And what is your tau xy? It is minus dou square phi upon dou x dou y. Okay, so this is all about this question number 9. And so I have written these. These are used in some other questions when you solve Airy stress function. Like there are questions where you have given as a plate and stress is acting on these faces. So we have to use these and we have to solve those questions. Now next question. So next question is from compatibility equation. So what is given? Consider the plane strain field given by epsilon xx, epsilon yy, and gamma xy. The relation between A and B needed for this strain field to satisfy the compatibility condition is. So guys, in this question, first we know plane strain problem is a 2D problem. And we know for 2D problem, we have only one compatibility equation. And what is that compatibility equation? Dou square dou x dou y gamma xy is equal to dou square by dou x square epsilon y plus dou square by dou y square epsilon x. Okay, this. Now you guys can here substitute gamma xy, here epsilon y and epsilon x, differentiate and equate. So when you do this, from here what we get? B equal to epsilon y is given in terms of a x square plus y. So what we get? If you differentiate twice, you will get 2a, and here again if you differentiate this with respect to y twice, you will get 2a. So what we get? B equal to 4a is our answer. So D is the answer. So any doubt guys in these two questions? So these are the easy questions from basic elasticity. Okay, basic elasticity. And in GATE 2020, there are many questions from basic elasticity. So these are the two questions among those two. Okay, so let's see next question. Yeah. So what is the question? Three long and slender aluminum bars of identical lengths are subjected to an axial tensile force. These bars have circular, triangular, and rectangular cross sections with same cross-sectional area. If they yield at F circle, F triangle, and F rectangle respectively, which one of the following is true? Which one of the following is true? Now guys, here we know for any bar or rod, what is the stress? What is the stress guys? Stress is always sigma induced stress is what? P by A. Now what is given here? Material is same. Okay, so the yield strength value will be same. Okay, and another thing, what? Even they are different cross section. One is a triangle, circle, and rectangle, but what happened? This cross sectional area is same. This cross sectional area is same. You can see with the same cross sectional area. So my this sigma applied will remain same. Will remain same. It is same for all three cases. Okay, if your f circle is equal to f triangle is equal to f rectangle, so they yield. Okay, so what is given, which one of the following is true if they yield at this f circle, f triangle and f rectangle? Okay, so which of the following is true? Okay, so why these are the these should be same? Because we know at yield your sigma applied is equal to sigma yield, and this yield stress doesn't depends on what, on this applied loading or applied cross section. So this is the same in all the cases. So in every case what we will find, uh, f circle will be equal to f triangle will be equal to f rectangle. How you can see, this sigma applied is nothing but what, your f circle upon f circle area. Now this is fixed for a particular material and cross section is same. So what I see, my fc is coming as sigma y into a, same way what I will get, my f triangle will be also coming as sigma y into a, and your f or rectangle is also coming as sigma y into a. So what we see finally, your f circle is equal to f rectangle is equal to f triangle. Okay, so this is what true. Is it clear guys? Any doubt in this, why these are equal? See, these are applied forces. If they yield at, okay, f circle, f triangle and f rectangle, so these all three will be same since the cross section is same. Okay, if your cross section is not same, if your cross section is not same, then what is the case guys? If I say my cross section is not same, so what I say, suppose my a circle, a circle is greater than a triangle is greater than a rectangle, which will be the correct answer guys? In that case, which will be the correct answer? If areas are not same for different cross section, which will be the correct answer? Hmm? No. See, you can see your load is directly proportional to area, right? Anirudh, load is directly proportional to area. So if area is more, load will be more, right? So which is the correct answer? Yeah. So option A will be correct. If it is a reverse, like a circle is less than a triangle less than a rectangle, what will be the correct answer? Or B will be correct answer. So this is how you guys have to think. Okay. Clear? Any doubt, guys? I think this we have not done in our during classes. So this question is good. Simple question, but good question. Yeah. So any doubt, guys? You guys can speak also. Unmute and speak if required. Okay. Let's see next question. Yeah. This was said in group some days back. Okay. So read the question. The positive high angle of attack condition is obtained in a steady pull-out maneuver at largest permissible angle of attack of the wing. Under this condition, at which of the following region, at which of the following region of the wing does the maximum tension occurs? Does the maximum tension occur? So guys, look into this question, what we see here, first of all, if you see your wing, aircraft wing, okay, and the aircraft is flying, so how your wing deflects? Your wing deflects upward, right? Yes or no? Your wings deflects upward. So what happened? On this top part, there will be compression, and bottom part, there will be tension. Okay. So now in this question already asked where maximum tension occurs. So your option 1 and 2 is ruled out, because at 1 and 2, this is the cross section of the wing. Okay. So at 1 and 2, there will be only compression. So answer can be fourth and third. But we know your lift, okay, uh, your lift will be passing through center of pressure, right? CP, yes or no? Your lift passes through what? CP, right? Right. And usually we know where this CP lies. Where CP lies? It will be closer to, you guys know, right? Aerodynamic center and center of pressure, right? So you usually lift passes through center of pressure, right? But it may vary, but usually it will be closer, right, towards leading edge. Okay, so you guys know this lift will be acting through, we consider through aerodynamic center with a pitching moment, right? Am I correct? I have forgotten these flight mechanics concepts learnt long back. Is it correct? At aerodynamic center, we have lift plus pitching moment, right? Yes or no, guys? Because aerodynamic center is your cross-sectional properties. Okay, so what you see, this lift has a bigger arm. If you take the length from this section 3 compared to this, not from section 3, what I say at the compared to point 3, if you compare with point 4. So when you have a bigger moment arm here, you know the bending moment will be more induced, okay, at this point 3. So you will have more tension at point 3 compared to point 4 if you go from leading edge to trailing edge part. Clear? So here two things we have to consider. If you look this view, if you look this view, then uh, from this view, whatever tension is happening at fourth and third should be similar, considering the distances along, span of the wing. And but when you go from leading edge to trailing edge, you know your lift will be acting through aerodynamic center. So point these three will have a bigger moment arm, so it will have a more tension. Okay, so clear? Is this clear? What is the answer? Why 3.3 is the correct answer, guys? You have to understand from these two perspectives. From this free body, okay, where we see always upper surface of the wing have compression, lower surface has tension, and then look into leading edge to trailing edge, how the load distribution is there, or how your lift and the pitching moment acts, and where it. Okay, fine. So let's move to question number 24. Okay, read this question number 24. A thin walled beam of constant thickness shown in the figure is subjected to a torque of 3.2 kilonewton meter. If the shear modulus is 25 gigapascal, the angle of twist per unit length is, the angle of twist per unit length is. So guys, we know uh, this you can use the simple torsional formula also here, considering one thing, torsional constant, or already we know the angle of twist per unit length for thin wall. So how it comes, we know T by J equal to G theta by L. So twist per unit length, they ask theta by L is what here, if you find, it is T by G GJ. Now here, what is the J, which is important? So we know J for closed section, it is a torsional constant and it is given by what? 4am square upon uh, integral ds by t. Okay. So what is the am here? Is it cross sectional area or material area? Here m means mean dimension. M means mean dimensions. It is not material. So it's a cross sectional area, guys. Okay, it is a cross sectional area. In case of torsion, it's a cross sectional area. So you know what is the cross sectional area here? It is 400 into 100, and thickness is how much? So thickness is 2 mm. This is mm square. So first, guys, find out J. So how we can find J? So J will be 4 into 400 into 100 square upon, now integration ds by t. So how we find? Like you can see here, throughout your thickness is same. So total peripheral length is how much? It is 200, sorry, 400, 400, 100, 100. So it is how much? 2 into 2 into 400 plus 2 into 100 by thickness is same. So find out J value and then substitute here J value and find the theta by L. So what is the torque here? And make sure you guys convert all the units in meter or mm. What is the answer asked in radian per meter? But first I will find answer in radian per mm and then convert answer to radian per meter. Guys, make sure this unit should be correct. So find out, guys. So tell me the answer, guys. So what is the answer, guys? Yeah. So J is 1.28 into 10 to the power 7, right? In this is in mm. What will be the unit of J? What will be the unit of J, guys? I think mm power 4. Yeah, good. So what is the J value is coming? So J is coming as 1.28 into 10 to the power 7 mm power 4. Then substitute here, and then finally guys find the answer in radian per mm and then radian per meter. Yeah, yes, answer is 0.01 radian per meter. The final answer is 0.01 radian per meter. Now, Mr. Anirudh, tell, are these gate question tough or tougher than IGC exams, IGC questions? No, right? Usually no. But 2021 paper was quite good. Okay, 2021 paper was quite good. So you guys can solve. And one more thing I want to tell you guys. This is the simplest topic in thin walled structure, torsion of thin walled structure. Okay, so guys, do not miss to learn this topic. If any questions comes from torsion of thin walled, you should not do mistake. In fact, GATE 2021 question was from torsion of thin walled, but it was lengthy question. It was not tough. GATE 2021 thin walled problem was from torsion of thin walled, but it was quite lengthy. Okay. Otherwise, that question was easier than other, like if shear center problem or unsymmetrical bending question. If you take textbook questions. Okay. Now let's move to next question. What is the question? The value of Poisson's ratio at which the shear modulus of an isotropic material is equal to bulk modulus is. So guys, we know what is your shear modulus G in terms of E? G equal to E upon what? 2 into 1 plus nu. What is the K? K equal to E upon 3 into 1 minus 2 nu. Now they told here G is equal to K. What is the K? Bulk modulus. Okay, it is bulk modulus. So when you equate, what you see, E upon 2 into 1 plus nu equal to E upon 3 into 1 minus 2 nu. So E got cancelled. So what you see, 2 plus 2 nu equal to 3 minus 6 nu. So what will you see, 8 nu equal to 1, and from here nu equal to 1 by 8. Now guys, I will add few more things here. In GATE exam, they can tell what is the range of nu for any material. So the maximum value of nu can be 0.5. Okay, and minimum value of nu can be -1. Now how these upper and lower limits are set? These upper and lower limits are set based on G and K. Now you can see G cannot be negative. G cannot be negative means what? Nu cannot be lesser than -1. Okay, so if nu is less than -1, G will be negative. So since G should not be negative, same way K will be negative if you see here nu is greater than 0.5. So this is not possible, this is not possible. So the upper limit of nu is set by K and the lower limit of nu is set by G. So the Poisson's ratio for any kind of material varies between -1 to 0.5. Yeah. So next question is quite good. Okay, and it is a lengthy questions for many people because if they use different method. but I will solve these questions in a simplest method or simplest way. Only things you should be good in integration. So what, read this question first. A load P is applied to the free end of a stepped cantilever beam as shown in the figure. As shown in the figure. Just a moment. Okay. The Young's modulus of the material is E, and the moment of inertia of the two section of the length 2 meter it is and 1 meter are I and 3I respectively. Ignoring transverse shear and stress concentration effects, the deflection at the point where load is applied at the free end of the cantilever is. So guys, if you know energy method or strain energy method, we know the deflection at any point delta P is what? It is derivative of total strain energy by the load applied at that point. So using this expression, I will solve this question. So before that, I need to find my total strain energy stored. So we know what is the U for beam, where you have a varying property. So it will be in integral form. So it is what usually mx square dx upon 2ei. This is the formula for strain energy stored in beam. When you can have a varying moment, you can have a varying material property, or you can have a varying inertia. Okay. So if you see here, material is same. Okay. And your applied load, if you take, it is throughout. If you take, your shear force is P. Okay. If you take free body anywhere, but if you take your mx, your mx is what? Px. The moment at any section, it is px. Okay, but what it is changing? The cross sectional area is suddenly changing, so your I value is changing. So if you find your strain energy total, it will be what? It will be, guys, first 0 to 2. What is your mx? It is px whole square dx. What is 2? Material is E. What is the I value? It is I alone. Then 2 to 3. What is the moment? It is same Px dx. And what is the material? It is E. And what is the I value? It is 3I. So guys, can you integrate this and find this total strain energy, guys? Quickly integrate and find this total strain energy. So if you integrate, what you see, I can take 1 upon 2 ei out. So and I can also take p square out. So first integration is what? X cube upon 3, 0 to 2. Then I can take p square out. Then 6 ei out, and it will be again integration x cube by 3, 2 to 3. So further, p square upon I can take 6 ei, and this, if you put the limit, it will be 8. Then it is p square upon 6 3 is 18 ei, and if you take limit, it will be what? It will be 27 minus 8. So what we see, 8 p square upon 6 ei plus it is 19 p square upon 18 ei. Now take LCM, 18 ei, so 3. So 24 p square plus 19 p square. So what we get? 41, 41 or 43. 19 plus, so 43. Yeah. So 43 p square upon 18 EI. Okay. Now guys, already the given load is how much? 3 Newton. Given load is 3 Newton. So if I substitute, okay, first given load is 3 Newton. So this is what your total strain energy. Now if I find delta, it is what? Dou U by dou P. So from here, what we see, it will come as 43 P upon 9 EI. Now P is given as 3 Newton. So this will be what? 43 into 3 upon 9 EI. So this will delta will be nothing but 43 upon 3 EI. So what is the correct answer, guys? What is the correct answer? C is the correct answer. Now tell, is it tough if you use this? Mr. Rajat, can you solve please see this question with method of superimposition? Mr. Rajat, I will suggest we can solve this question using that. Usually method of superimposition you use if multiple loads are given. If multiple loads are given, whenever your cross section is varying, material property is varying, your moment is varying, best method is strain energy. If you want to use another method, it is given in IGC solution manual. That is, you can say kind of method of superimposition. Okay, Rajat? But I will suggest this is the easiest method. Okay, all right. Now let's move to next question quickly. What is given? The three-dimensional strain stress relation for an isotropic material written in a general matrix form is. So you can see your normal strain are given in terms of normal stresses, and here your shear strains are given in terms of shear stresses. Okay, shear strain in terms of shear stresses. Now guys, we know what is your epsilon xx. If you write your stress strain relationship, you know your epsilon xx, it is what? Sigma x by E minus nu times sigma y by E minus nu times sigma z by E. So if you compare this with this matrix form, what we see here, you can see it is what? 1 minus nu. Okay, and it is divided by E, 1 by E, 1 by E, 1 by E, and then this matrix has sigma x, sigma y, sigma z. So from this comparison, what we see here, guys, your A is equal to 1 upon E here, and your B is equal to minus nu by E. Now guys, we know the relationship between shear strain, shear strain and shear stresses. What is the relationship between shear strain? You know gamma is what? Gamma xy is what? Tau xy by g. And what is the g value, guys? We know already we have written it is 2 into 1 plus nu upon E, because g is what? E upon 2 into 1 plus nu. So then it is multiplied by tau xy. Now guys, if you see here, sorry, not B, it is C. C is minus gamma upon E if you compare this matrix. Now what is the B? If you see B, your B value is nothing but this. So this is what? 2 into 1 plus 1 plus nu upon E is what your B. Now I can divide, it is B by 2 is equal to what? It is 1 upon E plus nu by E. Now guys, further 1 by E is what? A, and nu by E is what? Minus C. So substitute here. So from here what you get? You get minus nu by E equal to A minus B by 2. So what we got? C equal to A minus B by 2 is what my correct expression. So what is the answer, guys? What is the answer in this case, guys? So option D is the correct answer. Now, guys, again, it is not tough question if you always habitual writing things in matrix form. And in IGC, you know, we write always things in a matrix form. We have written already stress strain relationship in matrix form. If you go to IGC class notes, okay. So then you can solve this question. Now, next question, which is a good question, and it's a easy question. And here, if you know formula, you can't solve these questions without understanding concepts or orientation part. So what is given in this question? Read guys. For the state of stress shown in the figure, which one of the following represent correct free body diagram showing the maximum shear stress and associated normal stress? Okay, class guys may be knowing, but DLP guys, look into this. If you see this, what is the given data? Your sigma x is given as 18 megapascal, and is it positive? Yes, as per the sign convention, this is positive. Sigma y is given as 12 megapascal, is it positive? Yes. And tau xy is given as 4 megapascal. Yes, this is also positive, because this is our standard element where we say these are normal stresses, and corresponding shear should also go as per the normal uh, stress direction. You see here normal stress is in positive axis direction, so corresponding shear is in positive axis direction. Here you can see normal stress is in negative axis direction, so corresponding shear is in negative axis direction. So these are the value. Now the first thing which you should find in this question is what? The angle for maximum shear stress. So angle for maximum shear stress, we know theta 3. It is always given by what? Minus 1 by 2 tan inverse sigma x minus sigma y upon sigma x minus sigma y by okay. So here guys, if you look in this, this is what? Sigma x minus sigma y upon 2 tau xy. So this is the formula. So substitute all the values in this formula and tell me guys, what is the theta 3? Plane of max shear, how much it is coming guys? So it is coming as minus 18.43. Now guys, as per this, when theta 3 is positive, clockwise or anti-clockwise guys? In this, if you rotate this element in anti-clockwise direction, then your theta will be, when you rotate it in anti-clockwise direction, then theta is positive. But since theta is coming negative, that means your element has to be rotated in clockwise direction. So if you see the options given, if you see the given option, okay, we will see that also. But before that, a few more things we can find. So one thing is sure, the element has to be rotated in clockwise direction. Now value of tau max. Now one thing, I always told, hello, yeah, we will find now value of tau max. I told guys, when you find the tau max value, don't use this formula which you guys mostly knowing. Tau max formula is what? It is more circle radius, right? So it is what? Sigma x minus sigma y by 2 whole square plus tau xy square. Don't use this formula. Instead of that, what we should do, instead of that, we should use this formula, which is what? Generalized formula. What is that? Minus cs sigma x plus sigma y plus 2 tau xy cs. What is the c here? Cos theta. What is the s? Sin theta. So using this, guys, quickly find out what is the tau value is coming. Hmm? Guys, what is the tau value is coming? So if you look here, my tau value will be coming as 5 megapascal. Okay. Now it is coming as positive value. I will explain what is the meaning of this positive or negative here for tau. Now we also know what is the normal stresses on plane of maximum shear stress. It is always sigma x plus sigma y by 2. These are why this is what your normal stress on plane of max shear. So what it is? It is 18 plus 12 by 2. So it will be coming as 15 megapascal. Now guys, you know your shear stress and you know normal stress. And there are 4 options. So which will be correct option? So if you go option by option, if you see the option A, what you see? If you see the orientation, you will be seeing this orientation like it is rotated in anti-clockwise direction. Because if you see, your normal stress is tensile here, and if you see the corresponding shear stress is positive. So that means this can't be the answer. This can't be the answer. Now if you see the option B, this is option B. So in option B, what we see, this is rotated as clockwise since the theta is negative, and you can see this is what your normal stress, and it is a positive normal stress. This is what your positive normal stress. So since it is rotated in this direction, it is rotated like this. This is the positive axis, so corresponding shear should be in this direction, positive direction. So you can see it is going in positive direction. Okay. and we got the positive value, so that means B is the correct option. Now guys, we will see why C and D is wrong. Why C and D is wrong? You can see this is the option C. So in option C again, if you see the orientation, it is rotated clockwise, but normal stresses are compressive, so it is wrong. Your normal stress here, it is coming to be tensile, so C can't be answer. Now look into D. Since it is rotated clockwise, that's fine. Your normal stress is correct. But what you see, your shear stress is going in negative direction. How? See, this is rotated like this. So this is what your positive S and T coordinate. So corresponding to this, if your shear stress is positive, it should be in this direction, not in this direction. So it is going given in reverse direction. Okay, and it is coming 5 megapascal. So the only correct option is option B. Now someone will say, how sir it is problem? What you can do, you can take sigma fx equal to 0, and you can take sigma fy equal to 0, means force equilibrium. How you can find force equilibrium from stresses? You multiply these stresses into areas, okay, and you will find forces. So there will be only option B will satisfy this equilibrium. Okay, how you can do? Using force polygon, you can draw all the forces on this force polygon and then resolve accordingly. That we have done in classes to derive, stress transformations. So this is what important in this question number 34. Any doubt guys in this? Any doubt in this question guys? Why option B is correct? Anyone has any concern or doubt? See, again, if I say here, what I will like to tell you guys, if you see, this is the normal stress element, and if you, yeah, these are the my coordinates. Is it visible? So this is X and Y. These are my coordinate. Yeah. Now if I say it is rotated clockwise, so that means how my coordinate will look like. If it is rotated clockwise, you guys have to rotate like this. So this will be my positive coordinate, and corresponding positive coordinate will be this. So that's why you can see this is normal stress, and corresponding positive shear stress is like that. So that's why option B is the only correct option. Anyone has any doubt in this? Anyone has any doubt? If doubt, then say yes, otherwise no. I will move to next question. Yeah, so let's move to now next question. What is given? A solid circular shaft made of ductile material with yield stress sigma y equal to 280 megapascal is subjected to a torque of 10 kilonewton meter. Using Tresca's failure theory, the smallest radius of the shaft to avoid failure is. So guys, we know in this case it's a solid circular shaft, so it's a case of pure shear. It's a case of pure shear. So we know in case of solid circular shaft, what is the tau max value? It is always 16 T upon pi d q. And we know this allowable is what? Yield allowable. So what is the shear allowable? If you find shear allowable, it will be sigma y minus 0 by 2. Now we know at failure, what we see? At failure, your tau max will be equal to tau allowable. Okay. So It is what 16t upon pi d cube, and it is what 280 by 2. So from here we can find unknown diameter d. Okay, so guys, find out from here d, and answer is asked in centimeter, guys. So this is very important, guys. If you see the given units, it is given in meter. So if first I will keep find d in meter and then convert it in centimeter. Guys, do this calculation quickly. So if you keep it in meter, my torque is what? 10 into 10 to the power 3. And whatever I am saying, this is from Tresca's theory. Because Tresca's theory is what? Maximum shear stress theory. So it is Newton meter. And sigma y, it will be kept as 280 into 10 to the power 6 Newton per meter square. So if you find the d value, how much d value is coming, guys? So in centimeter, if you take, it is coming as 3.56 centimeter. So in meter, you divide by 100, you will get 0.0356 meter. Okay, any doubt? I think this should be fine. So let's see this question number, last question. So guys, last question today someone shared in group. So see this question, very easy question. There cannot be easier than this question. Okay, in GATE exam, there cannot be easier than this if you learnt well. So what is given? As shown in the figure, the beam has length 1 meter, is rigidly supported at the end, simply supported at the other end, under the action of uniformly distributed load of 10 Newton per meter. And this question is repetitive from GATE mechanical previous year's paper. The magnitude of the normal reaction force at simply supported end is. So guys, it's a simple formula for propped cantilever beam. The reaction at the propped cantilever is what? It is 3QL by 8. How it has come? We can derive this using method of superimposition. What it is? If it is a, this is B. So we know delta B will be 0. What is the delta B? Delta B will be due to this UDL. So it is QL power 4 upon 8 EI minus RP L cube upon 3 EI. This should be 0. Because this is what the deflection due to point load, and this is deflection due to UDL. So since at B deflection is 0, so and these are in opposite direction, because this will give me upward and this UDL will give downward deflection. So you get RP, and now everything is given. So it is 3 by 8. Q is how much? It is 10 and length is 1. So you get answer 3.75 Newton. Yeah. So I think we are done with this part of structures part.